For these guys, it says to classify each parallelogram. And once again, we're just looking for any of those special properties that we've been trying to find. Okay? And so when we look at something like this, it just says, hey, classify the parallelogram. So we're going to assume that it's a parallelogram. But then we look for the additional properties to see, hey, does it fit the mold of a rhombus or a rectangle or a square? Okay? And so if I look at this first one, the first thing I notice is that the diagonals are perpendicular. They come together in a 90-degree angle. So because they're perpendicular, I automatically know that this thing is a rhombus, okay? But then as I look around at this thing, if I start piecing together the measurements that give me, these pieces have to be 7 because they bisect each other. This piece has to be 7 because, again, it bisects the other one. And so when I look at the total diagonals, the diagonals themselves are each 14, so the diagonals are the same as well. So when I look at this parallelogram, the diagonals are perpendicular, making it a rhombus, but the diagonals are also congruent, which tells me it's a rectangle. Well, that's how I know now that it's actually a square, because a square just basically is a rhombus and a rectangle together. Okay, so this one's a square. If I look at the next one, same kind of thing here. I look at this guy and I say, okay, well, right here, I know that these pieces are going to be 6 and 8 respectively, because parallelograms, they always bisect each other, so we can kind of fill in those measurements. But now the question is, when I look at this, well, the diagonals aren't the same, so it's not a rectangle. So we can safely say it's not a rectangle, which means it's not a square. We just need to check to see if it's a rhombus. Well, I need to see if these diagonals are perpendicular. And right now I don't have any angles, but let's think about one of these pieces. If I think about just this piece right here, let me take it off to the side. That's a triangle, and it's a triangle with 6 and 8 respectively. I could do something like this. I could compare the sides looking at the Pythagorean Theorem, because that would tell me if this thing is a right triangle. And so for this particular one, I want to know if this is a right triangle. Well, the problem is I would need to know this side. But if I did my Pythagorean Theorem, out of curiosity, if I found this, be 6 squared plus 8 squared equals c squared. And I finish solving this. That's going to be 100. I take the square root, so I get c equals 10. So basically, if one of these sides, if I told you one of these sides was 10, then I would know that this is a right angle. So right now, frankly, I don't have enough information, okay? So I can't say that this is any one of my special parallelograms. The only thing I can say is that it is a parallelogram, okay? If I look at the next one is basically the same example, but this time one big difference. I said, hey, the side length this time is 10, which means we already kind of did the work on this. As we kind of look at this thing, it's the same example. And so if I change it just slightly and told you that one of the sides is 10, well, now you can say, because of the Pythagorean theorem, that this is a right triangle, which means this is a right angle down in the corner, okay? And so now I can see that the diagonals are perpendicular. So now I could call this one a rhombus. Okay? And so as you kind of look at that, it's just a matter of determining, okay, what information do I need to say that this thing is a rhombus versus a parallelogram? And in this case, I have that thing that I need, okay? If I look at this one, once again, I look at the information that's given. It gives me one value for the first diagonal. So it gives me this entire length right here as 9. And then it gives me this little piece right here as 4.5, okay? But because it's a parallelogram, the direction said that, I know that this piece is also 4.5, which means now I know the whole thing, well, has to be 9. So BD equals 9. Now I can see that the two diagonals are congruent, which means this thing has to be a rectangle. I also can't make any determination about whether or not the two diagonals are perpendicular. There's not enough information for me to show that, so I'm going to assume that they're not perpendicular right now. So the best I can do here is say that it's a rectangle, okay? But if I could find out that the diagonals were perpendicular, then instead of just being a rectangle, it would be a square, okay? So we look at the information that's given, look for the properties of a rhombus, because that'll tell us if it's a rhombus. Look for the properties of a rectangle, that'll tell us if it's a rectangle, okay? Look for the properties of a square, which is rhombus and rectangle. That'll help us determine if the thing is a square, okay?